Hello. Welcome to another week. So today we're going to, or maybe in this week, we're going to learn about parametric equation and how to take derivative of parametric equation. So our goal is to understand Apex chapter 10.2, and in the next video we'll learn about Apex chapter 10.3. Okay. So first of all, our goal is to understand what is parametric equation or parametric curves. Now remember, what is a curve? The curve is probably some sort of geometric figure on the 2D plane or in the 3D plane, right? But the point is, to mathematically describe a curve, we need to specify some sort of relation between its x and y coordinates. Meaning, for example, if my equation, maybe if I consider this parabola, for example, then the parabola is depicted by the equation y equals to x squared, meaning at x coordinate, the y coordinate is x squared. So a curve is a collection of points x comma y such that y has some sort of relation with x, right? For example, in this situation, in this situation, the relation between x and y coordinate is that the y coordinate is nothing but the square of the x coordinate, right? But it is very possible that there is not any um, a well-described relation between y and x. For example, one may consider this. For any real number t, we may consider square root of 1 minus t squared. Okay, so this is the x coordinate, this one is the x coordinate, and this one is the y coordinate. And t can vary. So, okay, it is not too bad. You can actually write down the equation here. But if you try to draw the curve would look like this. Okay, just pretend that this is a semicircle. So the curve depicted by this set of points is actually a semicircle. So, okay, at first glance, you might see that there is not a direct relation between y and x, but actually what is happening is that the relation between y and x is y square equals to uh, 1 minus x squared. This is the equation. Okay. But you can see like there are two possibilities. Either y is square root 1 minus x squared or y is negative square root 1 minus x squared, right? So this part only describes this thing. Makes sense? So this is a equation of, this is a parametric equation where I have two different formulas for the x and y coordinates. So let me just try to show you the different definition from the textbook. This is from the Apex calculus. So for a parametric equation, the x and y coordinate is given by two different functions, ft and gt. For example, in this situation, as you can see that f of t is t and g of t is square root 1 minus t squared, right? And we say that the curve is a curve of the parameter t. So I suggest you look at the examples in the textbook, example 10.2.4 and example 10.2.6. These are all on how to actually plot a parametric equation, meaning you will vary t and each value of t will give you a set of coordinates x and y, and you keep plotting the x versus y points on the curve. And as you like take more and more values of t, you will keep getting more and more points that will give you actually a curve. So look at 10.2 point. It's not too difficult to understand. So let me do an example. This is a very interesting problem. So I'm giving a parametric equation. So you will be given a parametric curve like this. Find E such that the curve crosses itself. Now see, when a curve crosses itself, it means that the x and y coordinate are being equal, right? Otherwise, it's never possible that the curve is actually crossing itself, right? So that means, so if the curve cross itself at x, then at x comma y, then x is equal to y, right? So you have to solve for t. So solve for t in the following equation. How do you solve it? Well, see, the right hand side is t minus 3. Well, oh, I'm extremely sorry. I'm extremely sorry. Yeah, sorry. So yeah, ignore whatever I just said until this point. See, the curve cuts itself at x of t comma y of t. Say for some value of t, right? But notice that the curve is actually moving as a function of t, right? So it must be the case that that means for some t and some s, you must have the fact that xt, that means the x coordinate is actually becoming the x coordinate at s, and the y coordinate at t is becoming the y coordinate as s, right? So now solve for t and s. So that means t cube minus 5t squared plus 3t and here t square minus 2t plus 3 a square minus 2s plus 3. Okay, how do you solve it? Well, this one, yeah, this one is kind of difficult to solve in the sense that you have to use the quadratic formula. So remember that t square minus 2t plus 3 is actually negative 2 plus minus root over, yeah, my bad. Let me write it down more carefully. Has roots t equals to negative 2 plus minus square root of 4 minus 12. So we have to do something like this. So first we have to solve for t in the second equation. I mean, there are no actually better way than doing this. So this is minus s squared plus 2s equals to 0. That means t equals to 2 plus minus square root 4 minus 4s square minus 8s over 2. So if you solve it, you can actually see that it is 1 plus minus. Yeah. Which is nothing but uh, which is, as you can see, is equal to either 1 plus s minus 1 or 1 minus s minus 1. So which is s or 2 minus s. Right? Now you have to substitute 2 minus s back into this equation to actually find out the value of t here. And you can see t is either negative 1 or 3. Anyway, this is not an easy problem, I must admit. So don't worry, I'm just trying to give you a hint of how parametric equation actually works. Okay, now let's move to 10.2, which is that we are going to convert a parametric equation to the usual form. For example, uh, yeah, I mean, you can consider this equation, for example. Consider the curve y equals to x squared. What is the parametric equation? Here it is actually very easy to find out. So say if x is t, then you can see that y is nothing but t squared, right? So the parametric equation is t comma t squared, right? So f of t is t, g of t is t squared, and your parametric equation is ft comma gt. Okay. Okay. So let's do some more problem on converting the rectangular coordinate or rectangular curve to parametric. So this is a very popular problem as in the textbook. So I'm doing one problem from the exercise. Find parametric equation for the given rectangular equation using parameter t. And what is the parameter in this case? dy equals to dx. So let's look at one of the curves. So say maybe the rectangular equation is y equals to 3x squared minus 11x plus 2. So this is my rectangular equation, and using the parameter t, so t, okay, solution. So first, find what the parameter is. Find what the parameter is. And you see, you already have the definition of the parameter. So the parameter t is given by the formula dy dx. So first find out what dy dx is. So y is 3x squared minus 11x plus 2. So this is nothing but 6x minus 11. So this is your parameter. With respect to this parameter t, so using this t, rewrite x and y in terms of t. So see, t is 6x minus 11. I have to write x in terms of t. That means 6x is t plus 11, meaning x is 1 over 6t plus 11 over 6. So this is the formula for x in terms of t. On the other hand, remember that y is 3x squared minus 11x plus 2. But you have already written down x in terms of t, right? So plug everything back. So this is going to be 3 over 6 t plus 11 squared, right? Minus 11 over 6 t plus 11 plus 2. Simplify everything. So this is 3 over 6 t square plus 22t plus 121 minus plus 2. Gather everything. So 3 over 6 t squared plus 11 minus 11 over 6 t right? Plus 363 over 6 plus 2. Simplify it on your own. Yeah, I mean, I don't need to be bothered with that. So this is 1 over 6, 3t squared, 55t plus 378, 75, sorry. I guess. So this is y. So the curve is this 1 over 6 t plus 11, 1 over 6, 3t squared minus 55t plus 375. This is the curve. I hope it makes sense. So this is how you can convert a rectangular equation to a parametric equation. Okay. You can go the other way as well. So parametric to rectangular. So let me find an example. Yeah, let's work with this. Yeah. So parametric equation is this: x equals to 4 cosine t plus 3 and y equals to 2 sine t plus 1. You have to convert this equation to rectangular equation, meaning that you have to write down an equation involving x and y only. How do you do it? Solution. So, okay, whenever something like this comes, always remember the fact that sine squared t plus cosine squared t is 1. So what shall I do? Well, we have to write down an explicit relation between y in terms of x, right? So notice that sine squared t equals to 1 minus cosine squared t, right? Right? Or actually, maybe let's do it in some other way. So first of all, try to write sine t in terms of y. How do you do it? Well, this implies sine t is y minus 1 over 2. And this implies cosine t is x minus 3 over 4, right? So that is so, then sine squared t plus cosine squared t equals to 1. Plug in the values, so that means y minus 1 over 2 whole squared plus x minus 3 over 4 whole squared equals to 1. And that's it. That's your parametric equation, like rectangular equation for x and y. And you can see that this is nothing but an equation of ellipse, right? So that's the fact. Okay, also you have to remember some of the well-known parametric equation. For example, parametric equation of ellipse and parametric equation of hyperbola and blah, blah, blah. So let me give you that formula over here. And there are also some special curve for parametric equation. Here I should also specify what smooth parametric curves are. So let me just copy the definition here. This is definition of smooth parametric curve. So parametric curve given by ft and yt, ft and gt is smooth if both f prime and g prime are continuous and not simultaneously zero. And it is called piecewise smooth if you can partition. So for example, a smooth parametric curve would just look like this, like you can draw it without any such jumps and things like that. Let me give you an example. Let me tell you what not smooth, like what smooth parametric curves look like. It is better to look at what not smooth parametric curve looks like actually. I don't think we have a name for that. So for example, this parametric curve. No, don't smooth it out. See, sharp edge, not smooth, or maybe some discontinuity. Also not smooth. Okay. So what does smooth parametric curve looks like? Essentially any curve that has like smooth bends and like no discontinuity. These are the so-called like smooth parametric curves must be differentiable. Okay. For example, if you consider this parametric curve as in the example, t cube minus 12t plus 17, t square minus 40 plus 8. So this is f, this is g. Then what is f prime? 3t squared minus 12. And what is g prime? 2t minus 4. Notice that both of these functions, f prime and g prime, are continuous. So that's fine. But at what points are these two 0? You have to solve for that as well. So that means t squared is 4. That means t is plus minus 2. And this means t is 2. So at t equals to 2, both f prime t and g prime t are 0. That means there is a cusp. There is some sort of cusp, like I mean a sharp edge at t equals to 2. These are called cusps. So not smooth. So both f prime and g prime cannot be vanishing. Keep that in mind. And that's all about 10.2.